Since electrical values of voltage, current, and resistance are standard for everyone, these values can be used in mathematical formulas. The first person to establish this relationship was a German scientist named George S. Ohm. These laws concerning electricity are known as Ohm's law, which is the basis for almost all electrical calculation. From his experiments, Ohm proved that in a DC circuit, the current is directly proportional to the voltage and inversely proportional to the resistance. Ohm's experiments resulted in mathematical formulas that we use to calculate different electrical values. In Ohm's law formulas, the letter E is generally used to represent EMF, or voltage. The letter I is used to represent the intensity of current, or amperes, and R is used to represent resistance. There are three basic Ohm's law formulas. Voltage is equal to the current flow times the resistance, or E equals I times R. Current flow is equal to the voltage divided by the resistance, or I equals E over R. And resistance is equal to the voltage divided by the current, or R equals E over I. A simple chart can help you remember these formulas. If you're trying to find the voltage and you know the current and resistance, place your finger or thumb over the letter that represents voltage, in this case E. The chart indicates that you should multiply I by R. If you are trying to find the current, place your finger or thumb over the letter I. The chart indicates that you should divide E by R. If you are trying to find the resistance, place your finger or thumb over the R. The chart reminds you to divide E by I. Assume that a 24-volt battery is connected to a resistor. Also assume that an ammeter indicates a current flow of 1/2 ampere. What is the resistance of the circuit? After determining the proper formula, substitute the values in the problem for the letters in the formula. The letter E is replaced with 24 because the battery has a voltage of 24 volts, and the I becomes 0.5 because the circuit current is 1/2 amp. The formula indicates that the resistance can be determined by dividing the voltage by the current. 24 volts divided by 1/2 amp equals 48 ohms, so the resistor has a value of 48 ohms. The symbol after 48 is the Greek letter omega. Omega is used to represent ohms in electrical formulas. Assume that a 36-volt battery is connected to a 144-ohm resistor. How much current will flow in this circuit? After determining the proper formula, substitute the values in the problem for the letters in the formula. The letter E is replaced with 36 because the battery has a voltage of 36 volts, and the R becomes 144 because the resistor has a value of 144 ohms. 36 divided by 144 is 0.25. There is a current flow of 0.25 amperes in this circuit. Assume that a circuit has a current flow of 2 amperes when connected to a 30-ohm resistor. How much voltage is applied to the circuit? Again, the formula chart indicates the correct Ohm's law formula to determine this voltage. Since the letter E represents voltage, cover the letter E in the chart. The chart indicates the formula E equals I times R. Substitute the circuit values for the corresponding letters in the formula. The letter I becomes 2 because there is a current flow of 2 amperes in the circuit, and the letter R becomes 30 because the resistor has a value of 30 ohms. Multiply 2 amps times 30 ohms. The answer is 60 volts. A more complete chart showing formulas used to determine values of voltage, current, resistance, and watts can also be used. In this chart, the letter P represents watts. The letter P stands for power.